The presentation of Uber supply demand gap analysis. So let us first introduce myself. I am Sayan Chakraborty, and here I am first introducing the tools that I have used for this analysis project. Firstly, for data cleaning and to make the data ready for analysis, I have used the Microsoft Excel. That is, using the Excel, I have introduced the data in a clean format, including all the errors, and make the data ready to be analysis. Nextly, and also I have created a insightful dashboard from using the pivot tables and charts in Excel, and links for finding impactful insights and comments on business objectives. I have used Python via Jupyter Notebook and MySQL. So for any project, it is first necessary to understand what is the problem statement. So let us first consider the problem statements, and before that let us first take a look at the dataset that is available for us. So this is the dataset. Here are the given primarily for the dataset. These are the given columns, that is request ID, pickup point, driver ID, status, request timestamp, drop timestamp, request time and drop time. These are the columns which I have extracted from request timestamp and drop timestamp to understand about the AM/PM of the request and drop timestamp. Nextly, to understand in which hour the request were registered, I extracted that by request hour and created a new column, that is using this formula, hour of that E2 is the request timestamp. Nextly, another column is in another column. Sorry. By mistake I am mistakeful. Okay. Here. And nextly, another column is trip duration. Trip duration is the difference between, you can see from it the formula, that is difference between the drop timestamp and request timestamp. Nextly, another column is introduced, that is trip category. Here I have introduced to the category of the trip with based of the trip duration. Here, if the trip duration is less than equal to 15, that is introduced as short trip. If that is less than equal to 30, that is a medium category trip, and if that is less than equal to 60, then that is a long category trip. And next, if the any trip is of duration of more than 60, that is very long category trip. And also, if for the not car available and for the uncancelled trip, I have used NA, that is not applicable. Now let us extract which day of the week the trip was registered. That is, using this formula I have extracted the registered the trip, the registration of the trip in which day was occurred from the request time. Now let us jump to the problem statement to understand our project. Here I have introduced some problem statement listed as what are the patterns of the ride demand across different hours of the day. That is, in which pattern the demand ride demand is occurred for different hours of the day. Nextly, when unfulfilled ride request occurred modes, that is unfulfilled ride request due to cancellation of the trip by the customer or by the driver, or due to no car available in the Uber market, occurred the most, in which day of the week this occurs the most. I want to find that. Nextly, how do trip completions and failures vary between pickup points, that is the city versus the airport. And the fourth one is, what is the distribution of the trip duration and how are they categorized, short, medium, long, very long, etc. And how completion of trips varies across different pickup points for different type of trips. That is, due to for these two pickup points, city and airports, how different type of trips are occur. I want to figure out this from this project. Now firstly, let us jump to the Excel part, and what I will show you what I have done in Excel. So let us jump to that. Now here in the description sheet, you can see that the steps which I have done in the project is listed here. And for data cleaning, after removing any duplicate values and missing values, firstly, for request drop timestamp, all dates are converted into similar formatted date format, year, hour, minute. And next, the steps I have those steps I have already shown to you. Now For problem statement, I have also introduced this to you. Now, based on this problem statement, to complete the business objectives, an insightful dashboard is created using pivot tables and pivot charts. Let's jump to the pivot tables first. Now, here is the pivot tables. You can clearly see, based on the problem statement, that is how the write demand across varies across different hours of the day, unfulfilled write requests for different days of the week, trip completion and failures vary between pickup points, distribution of trip duration, and how completion of trip varies across different pickup points for different type of trips. So here you can in the first table you can see for different request hour from 0 to 23 with the count of the status listed here, and for the next table is that is for which day the trip cancellation or failure occurred the most and due to which reason. Here you can see the no cuts available is more dominant for all of the days, and in the third table you can easily see that according to the pickup point how the trip completion and various failures are occurred here, that is counted. Now in the fourth column you can see that is how the trip duration based on the trip duration how the trip completions occurred, we can clearly see that. Now here the summary of the key insight, you can see the peak write demand is during early morning, that is 5 to 9 am on an average, and from the in the evening, that is 5 to 7 pm. You can clearly also see it from here, that is in request hour 5, 6, 7. Here I have highlighted it. These are the peak hours for the morning. Here also 8, 9 have a significant number of requests for the write, and here in the evening around the 5 to 7 pm the requests are on a significant number. Now the next significant key insight is no cards available is most frequent failure reason, picking on the Thursday and Fridays. Airport experiences are highest write failures with more unavailability than competition. Here you can easily see I have highlighted the key insights that are available from the table, and I have also listed this here. The city pickup point performs better operationally with more completed trips than failed ones. You can easily see that completed trips is the dominant part for the city, and the no cards available, that is a part of trip failure, is the dominant part for airport. Now the most complete rides are long or very long trips, that indicates that is demand of the ride in Uber is generally interzone or airport transfer rides. Now I will later show you the business suggestion that can be given to Uber for the more profitable situation. Now let us jump to the dashboard which is created by pivot charts. So here is a Uber analytical dashboard. You can clearly see here are 4 charts are available here, that is demand of trips for different hours of the day, unfulfilled ride requests for different days of the week. Nextly, the distribution of status of trip across different pickup points. I am showing you this, and the trip completed versus the pickup point. Here the key insight here also I have listed as. Here you can easily also verify that from the charts that is also available in the table in the previous section, that vehicle availability of airport is a major bottleneck and needs immediate intervention like fleet rebalancing and driver incentivization. That is unfulfilled ride request for days of the week. You can easily the vehicle availability is here. That is, you can see for the airports the no cuts available is the dominant part, which I have already shown you in the table part, and for the city part the trip completed is a dominant part. So we need to focus our concentrate on the airport to be in a more beneficial situation. Now the next key insight is high demand periods, that is morning 5 to 9 and in the evening 5 to 7 must be supported with predictive dispatching and real-time fleet tracking. So you need to track the people that are that have request for a ride in this time to be in a more beneficial and profitable situation. Now the third key insight is city pickups are more efficient and complete a large number of trips with fewer cancellation, indicating better operational stability. Pattern suggests need to redistribute supply across time and location to meet high demand hours and location effectively. That is, this pattern we can see it from here, that is for both airport and city. The trip completion are mostly of long type, but you can easily see for all type of trip category the difference is significant for airport respective of city. So you need to concentrate on the city need to concentrate on the airport based on the time when the request for the rides is most to be in a more profitable situation. So these are all the insights that are available from the Excel. Now let us jump to another useful tool which I have used in this project, that is using Python via Jupyter Notebook. So let us jump to that. So here you can easily see it is taking some time to load. So here is the analysis or exploratory data analysis on Uber supply and demand gap using Jupyter Notebook. So you can clearly see here is the project summary. I have introduced a project summary for short overview of this project. This project represents a comprehensive exploratory data analysis of Uber ride data in a metro city. The study investigates temporal demand patterns, analyzes trip outcomes across pickup points, and explores trip duration distribution. Through time series forecasting, we predict hourly ride demand, revealing future peak hours. Finally, we propose an optimized driver allocation by identifying the dominant trip categories by location, providing actionable insights for fleet efficiency and customer satisfaction. This project demonstrates skills in Pandas, Seaborn, Matplot library and basic forensic using stat models, making a solid portfolio asset for data science and analytics roles. Now let us also let us see for the SQL part also. Then I am showing you all the insights that are available for analysis. In the SQL, I also summarize the analysis by some parts. That is, firstly, I created a database that is named Uber analysis, then created a table from that available data which consists of the following columns: request ID, pickup point, stamp, the status of the trip that is completed, no cards available, cancelled, etc., request time, and so on, that is listed here. Next, I have loaded the data, and analysis part consists of mainly 5 useful charts. That is, what are the ride demand by hour, that is peak ride demand, peak hour which is registered for the ride by the users, the unfulfilled requests by hour, trip completion versus failures through pickup points, that is how the trip completions and failures occurred for airport and city. Nextly, the trip duration distribution for trip duration distribution, that is the trip duration based on the trip duration I have categorized the trip as short, long, medium, very long, and that distribution is shown as an insight. Nextly, completed trips by pickup point and trip type. Here also I have listed it as a query in SQL. Now let us jump to the Python notebook part to show you all the analysis. So this is the code for analysis. Firstly, I have loaded the data, and then for basic info this is the code, and there for basic statistical summary and filter for specific users. This is the basic statistical summary that are available for our data. There are in total 6745 rows and 12 columns, and I have also listed the column names. I have already shown you this from the Excel part, so I am skipping it. Now this is the dataset info. You can clearly see there is no non-null data, that is no missing data. I have already removed it in the. You can easily see driver ID, some IDs are missing, that is already listed here. This is the missing values part. Now let us jump to the statistical summary of the numeric columns. There is some basic statistical summary, that is mean, minimum, maximum value, that quartile value, count or standard deviation value for different columns available for this data sheet. Now the unique value count for per categorical column, you can re-verify it from the available data in the Excel sheet. That is 2 unique values for pickup point, that is the city and the airport. That is city have in total 3507 pickup point unique values as a pickup point, and here the status 3 unique values, that is the trip completed, cancelled or no cards available. Trip category here also 3 unique values. You can easily see that the short trip are no available in our dataset. That dataset mainly consists of long, very long and medium type of trip. Now this is the we have completed for 5 basic charts to visualize the insights that are available from this data, that is ride demand across hours, unfulfilled ride requests by hour, completion versus failure by pickup point, redistribution of distribution of trip duration, that is how the trip duration based like the very long trip or the long trip or the medium trip are distributed, trip computation by pickup point and trip category. Now let us jump to the insight PDF and I can show you all the insights from there. So here is, I have already shown you the project summary. Let us project summary. So here I have already shown you the project summary, but here are the steps that are done here, that is data loading and understanding, univariate and bivariate analysis, trip duration insights. I will show you the trip duration insights in detail. It is a visualization I have already shown you based on the problem statement as listed above. These are the meaningful charts that are created. I also used some statistical model theories for advanced analysis, that is integrated a time series forecast model to predict the future ride demand, proposed logic for driver allocation optimization based on pickup location and trip category. Now what are the conclusion recommendation? Here also you can see that summarize major findings around demand trends, service failures and trip patterns, provided data driven recommendation to optimize driver availability, reduce cancellations and improve operational efficiency. This structured analysis not only reveals core inefficiencies in Uber current ride request system but also provide actionable insights to enhance reliability and customer satisfaction using data science techniques. Here I have also encoded the project GitHub link here. You can easily check it out, my project, all the analysis from here by clicking the link. Now here the insights that are available from Excel. I have already told you this, so I am skipping the part for now. Now respective charts that are available from Excel that are listed here, you can easily verify that. I have already shown you in Excel datasheet, that is in Excel analytical dashboard. So distribution of status trip across pickup points, the no cards available, that is a part of trip failures that is dominant for airport, and no card, sorry, here I have by mistake skipped the airport and city column from while taking the screenshot, sorry for that. So trip computation pickup point, here you can also verify the distribution of the trip along the defined pickup points. Now I have also shown all you these insights that are available on Python and SQL. It is also listed here. Here are also another all the details that are statistical summary based on the dataset that are available to us. Now let us jump to the charts that are available from Python. So this is the distribution of the request for defined hour. Similar from Excel, you can easily show the requests are higher in case of 5 to 9 am in the morning, and in the evening 5 to 7 am the request have a huge peak. Now for unfulfilled ride request by hour, you can easily see that no cards available in a dominant part, that is in here that cause the trip failures, which indicates we need to redistribute the drivers as per the request time and pickup point to be in a more profitable situation. Now the trip computation and failures by pickup point, here the three categories, that is trip completed, trip cancelled or no cards available based on the airport. You can easily see that cancel part is not that much in airport, but the no cards available is a dominant part for the airport as a pickup point, which as a whole introduce a large peak for a trip failure in airport. And in the city, you can easily see that city for the trip completed as a dominant part. So you need to concentrate our focus in the airport, and also need to concentrate our basic focus for city to be in a profitable situation. Sorry. So it has jumped to another chart, that is distribution of trip duration. So you can easily see there is a almost bell-shaped curve for the distribution of trip duration, and the most of the trips are based on 50 to 60 minutes, and there are some trips also from the 30 to 40 minutes and some 60 to 70 minutes. So on an average 40 to 60 minutes is the trip duration for our data set. Now nextly, the trip category distribution by pickup point. Here you can also verify it from the Excel. The same picture is available from here. Now let us jump to the insights that are available from these charts. So firstly, a morning peak. A sharp increase in demand is observed from 5 to 10 am, aligning with the morning office hour. Evening peak. Another surge appears from 5 to 9 pm, likely due to office return traffic. Lowest demand is minimal between 12 to 4 am, a typical off-peak time. So here is the observation that this data exhibits clear bimodal demand pattern suggesting Uber must ensure maximum driver availability during early morning and evening periods. Chart 2, that is based on unfulfilled ride requests by hour, you can easily see that is cancellation are peak in the 5 to 9 am and no cars available case surge dramatically from 5 to 9 pm, especially at 6 to 8 pm, hinting a major supply shortage during evening peak hours. We can easily have already seen that for the evening, that 5 to 9 is the evening peak hour, and in that time the no cars available is affecting the profit for the Uber. So here is a recommendation: increase driver incentives and shift planning for evening hours to reduce no car available cases. Nextly, another chart, that is trip computation and failures by pickup point. Here I have already seen that for airport the no cars available is a dominant part causing the trip failures, and for city the trip computation has a higher rate than the failure part. So inside the city face both supply and reliability issues, while the airport faces a supply gap. Driver allocation needs to be optimized accordingly. That is distribution of trip duration. Most trips fall between 30 to 70 minutes with a bell-shaped distribution. The peak is around 50 to 60 minutes, suggesting a common average ride length. Very few trips are under 25 or over 80 minutes, marking those as outlier or special cases. So majority of trips can be categorized as medium or long, which should influence pricing models and estimate time of arrival algorithms. Trip completed versus pickup point, you can easily see that for long trips both airport and city pickup points contribute significantly, with city slightly higher. For very long trips city again outperform, and also for the medium trips city again outperform the airport. So we need to concentrate our focus in airport as well as in city to be in a more profitable and beneficial situation. So here are the suggestions that are given to Uber, that is dynamic driver allocation. Reallocate more drivers to high demand zones, especially city during morning and airport during evenings. Consider location-based incentives to encourage drivers to position themselves strategically. That is, introduce more drivers in airport in the peak hours with more incentives for the drivers, so that no cars available can be reduced, which is a major cause of trip failures. Next, the search forecasting and planning. Implement of a demand forecasting system using time series models to primitively plan for search hours and minimize no car available instances. Reduce morning cancellation by improving estimated wait times and showing driver ETA upfront. Offer ride credits or auto scheduling options to reduce morning rider or drop-offs. The airport strategy to introduce a dedicated airport queuing system for drivers with a better incentive during peak flight times. Create partnership with airports to create a holding area for active Uber drivers. Trip duration profiling. Use the duration profile to design optimized pricing and improve ETA prediction and cluster trips for potential carpool or ride share matching. Now let us jump to the advanced analysis, that is mainly based on the forecasting using some time series model. So here using some time series model, the picture which I have get, that is forecast of time series. Here is the request demand, recent demand, and we have seen that demand is varyingly for in this section of the amount of section for the request, and this is the range, or this is the linear prediction for the request in next 24 hours, that is can be given from this data. Also recommended driver allocation based on pickup and trip type. Here is the available, here is the picture that is based on, and here we can say that allocate more drivers at airport for long trips and allocate more drivers in city for long trips. That is on an average we need to allocate more drivers based on the peak hour that is available from our data to be in a more profitable situation. So here we can conclude that this analysis of Uber's data uncovers strong demand and peak during morning and evening hours with significant service failures during this time. Cancellation dominance in the city during mornings, while no car available is the common at the airport during evenings. Most trips fall in the 30 to 70 minute range, suggesting scope of optimizing trip-based pricing and ETAs. So these are the recommendations I have already discussed. So on an average, this is the project that I have done for Uber supply demand gap analysis. You can also connect to me through the GitHub link that I have already shown to you in the starting of this project. That is here, sorry by mistake I have touched it. sorry. Here for the GitHub link that I have given to you, you can clearly join it from me. This is the GitHub link. By clicking it from here, yeah, this is the GitHub link. By clicking it from here, you can clearly join me. I can show you this page. Here I have already all the data set available, and based on the analysis I have all filed the I have also filed the PDF as well as the Python file, SQL file, the Excel data sheet, and here I have a summary of the data of the analysis that I have done. So thank you. This was all for my analysis of UBER data analysis as a part of